Ever wondered why your phone's AI assistant sometimes takes forever to answer a question? Or why some models sound like they're talking to themselves, saying, "Wait, let me think again"? Well, researchers just found a way to make AI smarter and faster, without losing its ability to solve tough problems. Let me break it down. Large AI models today are like super smart students who write out every step of their homework. They use something called chain-of-thought reasoning, where they think aloud to solve problems, from math puzzles to complex logic. But here's the thing, this process can get stuck in loops. You'll see phrases like "wait," or alternatively popping up like the AI is second-guessing itself. These extra steps slow things down and use more computer power. So how do we fix this? A team of researchers created NOWAIT, a simple but brilliant idea. Instead of letting the AI chatter to itself, NOWAIT suppresses those distracting thinking tokens. It's like editing a script to remove all the ums and likes. The message stays the same, but the flow is smoother and faster. Imagine your AI assistant is a writer. Instead of typing, "Wait, maybe I should check that again. Oh, and what if I tried this other way?" It just says, "Okay, the answer is D, no fluff, no extra steps." That's NOWAIT in action. And the results? Mind-blowing. In tests, NOWAIT cut the AI's thinking time by 27% to 51%, but the answers stayed just as accurate. It's like teaching a student to solve a math problem faster without sacrificing correctness. Why does this matter? Well, faster AI means better performance on phones, smart devices, and even self-driving cars. It also makes systems more scalable. No need to retrain the model from scratch. Just tweak the process. But NOWAIT is just one piece of a bigger puzzle. Researchers are testing multiple approaches to make AI reason more efficiently. Let's dive into 3 key methods. The first, NoThinking, tells models to skip the reasoning process entirely and just guess. Not great, accuracy plummets. Then there's TokenBudget, which forces models to be concise, like asking a friend to explain something in one sentence. Finally, O1 Pruner fine-tunes models to cut out unnecessary steps, like editing a long essay to keep only the best parts. The results? Some methods work surprisingly well, speeding things up without losing accuracy. Others, let's just say AI still has a long way to go. It's like trying to teach a toddler to ride a bike. Progress, but plenty of wobbles along the way. Now here's where it gets really cool. These models aren't just text wizards anymore. They're learning to reason with images, videos, and even math problems. Imagine an AI that can look at a chemistry diagram and a paragraph about reactions, then connect the dots. That's what benchmarks like M-Mini are all about. It's like giving AI a Sudoku puzzle and a mystery novel to solve at the same time, testing if they can juggle multiple types of knowledge. To test this, researchers used models like Kimi-VL-A3B-Thinking and QvQ-72B-Preview. Kimi-VL uses a mixture of experts system, where specialized submodels handle tasks like coding or math. QvQ-72B builds on a massive foundation to tackle complex reasoning challenges. Both are open source, so the whole AI community can learn from them. But it's not just static images. Researchers are testing models on video benchmarks like MMVU and VSIBench. MMVU is like a textbook for AI. Each question is crafted with expert annotations, forcing models to understand both what they see and the science behind it. VSIBench takes it further, using 3D videos to test spatial reasoning. Think of it as training AI to navigate a room or figure out how objects move in space, way harder than just identifying a chair in a photo. Take this, a video of a pendulum experiment. The question, how does adding a new object affect the pendulum's energy if there's no friction? The answer isn't obvious. But when researchers used a method called chain-of-thought, COTI, the AI walked through its reasoning step by step. It recalled that in a frictionless system, energy is conserved. Adding mass or changing the pendulum's length doesn't add or remove energy, it just redistributes it. So the answer? The pendulum's total energy remains constant, but its kinetic and potential energies shift based on position. So next time you see an AI solving a problem, remember, sometimes less thinking leads to more brilliance. Thanks for watching, stay curious, and let's keep exploring the future of AI together. Stay tuned for more deep dives into the science behind the tech.